I have here a small version of the solar collector made from aluminum foil, or my favorite potato chip bags, the shiny inside part. And onto that, we can put our 1 liter plastic bottle with an aluminum can, a dark aluminum can painted black. And this one has sat out in the sun long enough that the top of the plastic bottle has melted itself to the aluminum can. And for it to reach that temperature, that's way above pasteurization temperature. So in an emergency situation, you could rely on the plastic melting as a way to indicate that you've reached a pasteurization temperature. But it pretty much destroys the unit that you're using by deforming the plastic. So here's another unit. Same kind of a can, same kind of setup. Put it in the reflector, and inside of here we have our soda straw indicator. And when it's reached the right temperature, this is going to flip open, and you can tell that it's open by when you pull it out, and there it is, it's opened up. Now, not only is it opened up, but you can, after it's opened up, you can put that back into the can, and now you can use the straw to drink your liquid out of the can without actually having to tip the can over. You can just do it directly out of the can. So that's a nice feature of the straw indicator for pasteurization, or SIP as I like to call it. Our solar pasteurizer indicator is still intact, stuck together. And now let's check our digital thermometer, and I believe we have 161 degrees Fahrenheit, and that would translate into 71.6 degrees. Now let's talk about the brown bottle, glass bottle. And I have the pasteurization indicator, one of these, put in there, and it's gotten up to temperature, and you can look through the bottle, and you can see that the indicator has opened up, which is a very nice feature of the glass container, because you can't do that very well with the aluminum can. So this way you can see it, and you know that it's reached pasteurization temperature, and you can just leave it like this and let it cool down to room temperature, and then you're ready to drink it. So, and we can open it up, and we can remove the straw and see that we've got our separation. So here we have the straw, and we'll insert the chopstick into our mark, which is about the third of the length of the straw. We'll fold it back on itself. Okay. We're going to attach a clothespin just to hold everything nice and neat. We've got the surfaces of the straw are right up next to each other. No space in between. That's why I like the chopstick design. It really works well. And now I'm going to take my multi-temperature general purpose glue stick in this glue gun, and it's good and hot. Want to make sure that glue gun's hot, and we're going to put it right down in the groove between the two straws. We're just going to push it down in there, make sure it gets all the way in. Okay, then we'll do that to the other side. Okay, get it in both sides there. All right, now I'm going to come back, and I'm going to just give it another shot here on this side. So we got plenty. Don't want to skimp on the glue. Okay. There we go. So we have a generous amount of the hot glue melted to both surfaces of the straw, and it's being held in place by the clothespin, and now I'm just going to dip it in the water, and that'll cool it off. So we want to make sure that these are totally cool before they're put into general use. The adhesive, stays hot for a while. Safe drinking water for pennies, made out of recyclables, stuff that's in the environment being thrown away. Reuse it, make it into something that could save lives. That's what it's all about, right? Okay, so for more information on this and other great projects, visit recyclables.com. Thank you.